Hello, everyone. We're Group 2 of MN692 Capstone Project. Our topic of this project is analysis of vulnerabilities of codes using machine learning tools. First, let me introduce the team members of our team. My name is Wen Xiong, and this handsome guy is Jess Winder, and the girl in blue is our team leader Yu Xuan, and the girl in black, which is very pretty, is Xue Yingshi. So, introduction finished. Let me do the introduction of project client details. First, we really want to thank our industry client Jonathan Oliver, who is a very gentle and patient guy who has tutored us and helped us for almost half a year. He's from Trend Micro, which is a very popular and successful cybersecurity company with a good reputation. And we really want to thank Dr. Ammar Alazab, which has also helped us with a very long time. 1,000 thanks to you guys. So I'm gonna turn the video to Jaswinder.
Thanks, Adam. My name is Jaswinder Kumar, and I'm going to give you a brief introduction about our project. So, as we know, vulnerabilities are most common nowadays because of the availability of open source software. Our project objective is to discover how vulnerabilities affect the working of Linux operating system and successful implementation of a system that can find that kind of vulnerabilities that affect Linux operating system. And in our project outcome, we are going to compare multiple machine learning tools to find the one with the most accurate result that can be used to analyze the vulnerabilities in a given dataset. So in our client requirement, we are using 5 different machine learning techniques named as TLSH, SSDeep, SDHash, knife Bayes, and decision tree. So we are going to compare each machine learning technique results and find the possible reasons for the vulnerable code, and then we achieved a higher accuracy of vulnerability prediction based on the result that we obtained from different machine learning techniques, and then we analyze the result and find out which machine learning technique provide the most accurate result. So in our project design, our project is basically divided into 3 parts. In first part, we did a research, and in second part, we obtained a data set which was given by our project supervisor, Mr. Ammar, named as UNSW NB15. And in third part, we are going to implement 5 different kinds of machine learning techniques and obtain the result and find out which machine learning technique is most accurate. And let's moving to design approaches. We are using 3 different types of approaching in a design approaches in a project. The first one is static methodology, second one is dynamic methodology, and the third one is hybrid methodology. And we only focuses on hybrid methodology because it's a combination of static and dynamic methodology, and hybrid methodology provides us unique and more accurate results. And the next part discussed by my project partner Hussein. Thank you.
Hello, let me introduce our implementation process. We want to use the same database, which is a published training dataset UNSW MB15. First of all, we need to transfer the dataset into the format that TLSH and SSDeep SDHash recognize. We process this algorithm in Amazon web server because 3 groups of us doing the project with same client, and our client want us to share what we find, and he want to know what we're doing in the same page. And the second part is recap. We use a local PC to implement these two tools. Then Samantha will introduce this recap part further on. First, TLSH. This is what we got for the local sensitive hashing. As we can see, the results TLSH, this mean analyze folder 1,778 file compared with DOS folder 528 file log, and the result is correct. The correct mean when the situation is attacked or vulnerable, the actual situation is vulnerable as well. It's been correct. If it's predict in normal, but the actual situation is vulnerable, then the results will show wrong. But what is the results of the scores? In TLSH, the scores mean 0 means perfect match. This 2 file is definitely the same file, and actually it's the same file. And 1 to 100 means near perfect to weak match. So the higher score it is, it means the 2 file is large distance and it's much more difference. Then we could export these results to Excel file. Then we can further research in the detail of the results. So we also get the results of the overall accuracy. We can see that the total testing number is 644, and the number of correct is 537. So the overall accuracy is 83.4 accuracy. But we can see the reason might be shellcode and no shellcode and faster. It has lower performance rate. It might be because the shellcode and faster, it has similar situation with normal. So it will reduce the accuracy what we want to get. And next week up, that's welcome Samantha to introduce machine learning week up.
Weka is another machine learning tool that we selected to analyze the data because it's quite easy to understand and use due to its graphic user interface, and it can be almost used on any computing platform. It also had the technology to fully collect the data for preparation, classification, regression, and so on. 9U-BICE is one of the methods that we applied in Weka, and here is the result of 9U-BICE. But how it works? All the data analysis all based on the predicted class table. When we predict it at the positive, and it actually positive, it will be the true positive. When we predict it negative, and it actually the positive one, it will become with the true negative. So the result the result of the accuracy will be the sum of true positive plus the true negative and true, and divide all the for predicted class. So we can get the accuracy result of the 9U-BICE will be around 77%. And we will analysis the result in decision tree with the assume method, so we can get the result of accuracy in decision tree with 97%. So now pass to MN.
Okay, from the right side of the slide, we can see that the result of all the approaches. As we can see, the decision tree gets the highest rates with accuracy of 97.35%, and the naive Bayes got the lowest with just more than 76. So the reason why naive Bayes gets a lower rate, it might because it treats all the attributes as individual objects. And you can see that the SSD and SD hash, they didn't get a result. We think the reason is that the SSD and SD hash have no result due to the database size requirement. Talking about the limitations of the project, we think the biggest one is that we are lack of the in-depth knowledge of the data transforming. But we have used a data set that we get from the public resource. And the other limitation we think is that the insufficient use of SSD and SD hash, as I just discussed. So the conclusions of the project is very simple and clear. The first one is we have already transformed the theory from the first phase of the project, into practice in this phase. And the second one is the results of machine learning tools vary by using different algorithms. While the third one is the decision tree algorithm of Weka gets the highest accuracy of a single test. And the fourth one is that and it's the most important one, that the false rate lowers by letting the tools keep running and learning, which is the main purpose of the whole project. So these are the references of this PPT slides, and thank you. Say thank you.
Thank you.
Thank you.
Thank you. Bye.
Thank you. Bye.